We're going to look at solving triangles for missing sides when we have similar triangles. So a similar triangle is a triangle that has three angles that are the same and sides that are proportional. So if you take a look at this triangle down here, it would have this angle the same in both the little triangle and the big triangle. And these being parallel lines here, with the F pattern, this angle and this angle would also be the same, and subsequently this one and this one would have to be the same. So we have all these angles that are the same and just different sizes in the triangles themselves. In the other example up here, we have two right angles that are the same. We have an opposite angle right here, so there's the opposite angle theorem, and that would mean that the third angle has to be the same, and that would make those proportional. So the angles in the triangles are all the same, and they're just different sizes, meaning that they're similar triangles. So when we're working with similar triangles, we can set up ratios to find missing sides. In this case here, we're missing this side x. So what we do is we set up two ratios. On the top of the first one, I'll put the x, and then on the top of the other one, I'll put the corresponding side. In this case, the 38 here is the same side as the x, so I put that right there. And then we have the smaller triangle where we took the x from, so we go back there and get that side 25. So this is that from the same triangle. The x and 25 come from the same triangle. And in the large triangle, 25 and 15, that makes a side of 40. So small triangle, large triangle, and those are each pairs of matching sides. To solve this now, really straightforward, we just take that 25, move it over, and multiply it. So 38 times 25 over 40. When we multiply 38 by 25, we would get 950 over 40, and when we divide that out, we would get 23.75 as our result. So there's our first triangle. We calculated this missing side. That's 23.75 in the smaller triangle. And we just did it by cross multiplying that 25. So we took that 25 and just multiplied it on the other side and calculated it. Very similar idea on the other triangle. Again, with our similar triangles here, we have two right triangles. We're looking for the hypotenuse in this case, which is the x. And so that matches up with this hypotenuse, the 12. And sorry, that goes on the top. So there's the matching hypotenuse. So hypotenuse, hypotenuse on top, and then these matching sides on the bottom. Because the x came from this triangle, on this side we put the 16. And then the 8 matches with the 16 for the bottom of this one. And now I do some cross multiplying. Again, I take that 16, and to get the x by itself, I multiply it by the 12 on the other side. And we will get 24 as the length of this side here.